So now we are going to study about the fault zone classifications. So when we study fault, so we talk about the brittle rocks, or brittle fault zone and ductile fault zone. So in these two zones, different kind of fault characteristics appear. So in brittle, we generally talk about the breccias uh, and the fault gauge. In ductile, we talk about the myelonites and ultramyelonites and blastomyelonites. So based on the pressure, so they are divided into incohesive and cohesive. So if the pressure is less, then they are going to be incohesive, and if the pressure is more, then they are going to be cohesive. So if we make a table of this one, then let's divide the table into two parts. First is for the brittle rocks, or in this the fabric is random, because in brittle there is no fixed pattern of breaking, and in the ductile the foliation occur. Okay, so they can again, in this axis we first divide them as incohesive, and in incohesive the random factory fabrics are, first is the fault breccia. First is fault breccia. In this one, if there is rock, then there are more than 30% visible particle. So greater than 30% visible rock mass. So greater than 30% visible rock mass. And then comes the fault gauge. Fault gauge. In this one, the visible particle is less than 30%. So if this is a rock, so very less particles you will be able to see of rock mass. So in incohesive, there is no general classification for the foliated rock in this case. Then we directly come to the cohesive. Cohesive, first comes the glass type. So what are glass? They are formed because of quenching. What is quenching? Immediate cooling. Immediate cooling. And these glasses are called as pseudo-cataclysite. Pseudo-cataclysite. Okay. Now, again, if we divide, then the nature of the, again we divide them. Then comes the three things come. First is crush breccia. Crush breccia. Then comes the crush microbreccia. Fine crush breccia. Fine crush breccia. And the third comes the crush microbreccia. Then comes the crush microbreccia. So what is the difference? If we divide them basis of the grain percent, here the crush breccia, the grains are 90 to 100% are there, and here the grains are 0 to 10%. So this is how they divided. Then if we divide them further, we will get the protocataclysite, then ultra, then comes cataclysite, and then comes the ultra cataclysite. Then comes the ultra cataclysite. So in the same, if we talk about the uh, foliated rock, then at the place of protocataclysite we will have protomyelonites, At the catoclysite we have myelonites, and then ultra cataclysite we have ultramyelonite. So we will have myelonite, protomyelonites, then myelonites, then ultramyelonites. And these protomyelonites have the the percentage of 50 to 90 percentage. Myelonites have 10 to 50 percentage, and then it will have 0 to 10 percentage. And when the matrix increases so much, and then comes the blastomyelonite. So this is how the foliated and non-foliated rock. So while ending the answer, we can say that the Simpson's fault zone classification based on random fabric of brittle rock and foliated ductile rock are divided based on cohesive and non-cohesive or incohesive components. Okay, so this is how it is divided.